Hi students, and welcome to section 1.3 on reasoning and logic. This will probably be in several pieces because I am trying to make sure that it will be able to be posted in YouTube. The very first thing that we want to talk about is the definition of a statement. A statement is a sentence that's either true or false, okay? But it's not both. So it's one or the other. A negation is a statement with the opposite truth value of a given statement. For example, I might say, it is raining today. The opposite of that would be, it is not raining. Now, one of the things that you need to see when you start talking about negation is it's a little squiggly mark. Okay? P is true. And if P is true, then the opposite of P is false. That's a given all the time. So you might say that for something like, if I tell you that it's true that it's raining outside. Okay, and if that's a true statement, then to say that it's not raining outside would be false. And that just kind of makes sense. Some other definitions that we need, the word quantifier. Quantifiers are words such as all of the time, some of the time, every time there exists. A universal quantifier applies to every element in the set, and that would be like all, every, and no. Some is not a universal quantifier, okay? An existential quantifier applies to one or more elements in the set, and that would be something like some do this or there is at least one. Now, some examples of statements. If you have 2 plus 3 equals 5 as the original statement, to negate it would be 2 plus 3 is not equal to 5. Likewise, if you have 2 plus 3 is not equal to 5, to negate it would be 2 plus 3 equals 5. Now, remember, if you start out with a true one, for example, if this is the beginning, if 2 plus 3 equals 5, then the opposite, or to negate it by saying 2 plus 3 is not equal to 5, would be false. If this one is true, this one has to be false. Alright, a hexagon has 6 sides. We know that's true because that's what the definition of a hexagon is. And it does have six sides. Now, to negate that would be to say a hexagon does not have 6 sides. Now, this one's true, so that one has to be false. All students like hamburgers. Okay, that's a true statement. If that's a true statement, then it would not be true to say that some don't like hamburgers. Because if everyone likes them, then no people don't like them. And that goes back to that quantifier that we had, the universal quantifier. That tells you that every single one of them like hamburgers. And if that's the case, then we wouldn't say that some don't like hamburgers. So that would still make that false. If the original statement's true, then to negate it makes everything false. Some people like mathematics is true. Then no people like mathematics would be false because there are some who do. So these kinds of statements are just like some common sense things. But these are sometimes very difficult for students to understand. All right, let's look and try to negate each of these. There exists a natural number x such that x is 3x equals 6. So if you negate that, it would say there does not exist a natural number such that 3x equals 6. Or you might even say, like they did, for all natural numbers, 3x does not equal 6. Okay? In other words, we're saying here that there is a number x that makes this true. So if that's the case, then this one's going to be false. Okay? Number 5 says, for all natural numbers, 3x equals 3x. Okay? 3x is equal to itself. That's an example of the reflexive property, which we'll talk more about later in another chapter. But that's an example of the reflexive property because everything is equal to itself. Then to negate that, there exists a natural number such that 3x is not equal to 3x. And we know then that that would be false as well. So if the original statement is true, then when we negate it or do the opposite, then the opposite statement will be false.